Hi, good evening everyone. Welcome to the Beef Cattle Research Council's webinar on managing rumen health to improve productivity. My name is Tracy Herbert and I'll be your moderator tonight. I'm the Extension Coordinator for the Beef Cattle Research Council, or BCRC, which means that I have the very cool job of helping to share information and develop resources that allows you, cattle producers, and other folks in the industry to take advantage of scientific knowledge and innovative ideas or technologies. So I spend my time coordinating things like the written articles that you'll find on our website and in industry publications, distributing fact sheets, creating videos, and all those types of things. So you and 166 other people from across the country registered, as well as a few international guests, so welcome. As usual, about 70% of our webinar audience is cattle producers. And this session will last for about an hour. We may go a little bit longer, just depending on how many questions you've got for us during the question and answer session at the end. We are recording this session tonight, and I'll email out a link to everyone that registered, probably on Friday. And so if you miss hearing anything tonight, or you want to watch this again, you can. I also encourage you to take a few notes that you could look up later, and would also help you to remember more of what you hear tonight. Of course, you'll be able to hear and see tonight's presenters, but we can't hear or see you. So if you want to communicate with us, type into the small chat window in the control panel on the side of your screen. So if you have a question or a comment for me or any of the guest speakers, that's the place to do it. And feel free to send in questions at any time. We'll answer them all near the end of the webinar. And if your internet connection is a little bit slow tonight, it might help if you close the webcam window. And if you do that, that means that you won't be able to see us, but hopefully that the audio would come through a little bit more clearly and the slides will load a little bit faster for you if your internet connection is slow. Okay, so let's get started. So here's what we're going to be covering tonight. First, you will hear from our science director at the BCRC. Then we'll hand it over to Dr. Greg Penner, open it up to questions from you, and finish the webinar by letting you know where to find more information that you'll be interested in and can use on your farm or ranch. So with that, I am pleased to introduce our first guest speaker this evening, Dr. Reynold Bergen. Reynold is the science director at the Beef Cattle Research Council. And in a nutshell, his job is to talk about science to people in the industry and talk about our industry to scientists. So if you subscribe to the Canadian Cattleman magazine, you've seen a bit of what he does in the research column that he writes for every issue. So he's really the industry's go-to guy when it comes to all things science related, and because he's so knowledgeable and well-spoken about the spectrum of beef-related research, there's a lot of different topics that I would love for him to talk to you about tonight. And we couldn't decide on just one, so you actually get to decide what he'll cover in the next 5 to 10 minutes. So here's what's going to happen. I'm going to load a multiple choice question on your screen. You'll click on your answer, and then we'll see which option gets the most votes. So, would you rather Reynold give a 5-minute summary of who the BCRC is, what we do and how we're funded, or the value of research to Canada's beef industry, or how the beef industry is using research funds more efficiently? So your answers to poll questions like these are anonymous to everybody else that's on the line, so go ahead and place your vote. Give you a couple more seconds to get those in. Okay, let's see the results. So it was very close, but 43% of you selected how the beef industry is using research funds more efficiently. So there you go, Reynold.
Okay, can you see what you need to?
I think I've just switched you over there, so I think you should be able to take it away.
Okay, so it's good?
Yep, go ahead.
All right. So Tracy was indicating that we can't see you or hear you, but one of the benefits of my fancy headset is that I can understand what you're thinking. And I know that at least one of you was thinking that, oh, geez, I really wish there was a none of the above option in this question or list of options. But anyway, I'm going to run through a bit of a description of an initiative we got underway that I wrote about in the last Cattleman article, actually, and I'm kind of excited that you guys chose this because it's not the easiest thing to talk about. Anyway, what am I doing here? There we go. Okay, so the BCRC, which is us, we fund research all across the country. We're using national checkoff funds that you pay to support research, anywhere in Canada that comes up with a good proposal. Now, we're not the only ones who do that. Ag Canada also funds research across the country, but it's not just us and Ag Canada. There's a lot of other funders out there. Every single province has a beef producer group that funds research in some way, shape, or form. And every provincial government across the country funds research related to beef production. And every single province has some kind of a Fed-Prov research funding initiative. And there's other groups like NSERC that fund research all across the country, and some provinces have more than one provincial funder. And so it's a really, really complex funding landscape. And the problem is that even though it's really, really exciting that we've got all these different groups out there that are interested in funding research, the problem is that historically they've operated as silos and not done a great job of communicating with each other, and it's just really, really horribly fragmented. So nobody knows what anybody else's priorities are, nobody knows what anybody else is funding, and all the rest of it. So we started to get a little bit concerned about how that was affecting how efficiently research dollars were getting used. And so a couple of years ago, we did a survey. BCRC headed this up. We did a survey. We surveyed 25 different research funders across the country, both federal, provincial government, as well as beef producer groups. And we asked them for a lot of information about, give me a list of every project you funded over the last 5 years. What was the title of each project? Who was the researcher? Where were they? What were the objectives, and that sort of thing. It was a lot of work for these people to come up with this information, and kudos to them, because 23 of those 25 actually responded, and they gave me a list of about 600 different projects that have been funded that added up to about $85 million. And so we summarized all this information, and we sliced and diced and looked at it and thought, wow, there's some pretty interesting things here. Let's have a meeting. And so we convened a meeting of all these different funders, and we explained a lot of things to them, but I'm going to give you a couple of examples. And one was we asked the question about whether, as a collective group, we funders were really funding what we thought we were. And so all of those 600 projects that they provided us with, they could fall into these general priority areas like beef quality, food safety, feed efficiency, and so on. You can see the list. And then we looked at how often those different priorities were mentioned by the funders. And actually, they came out for the most part pretty evenly. Between 15 and 25% was roughly where we would expect that funding to go, based on how often the funders mentioned them as priorities. But then when we looked at where their dollars actually went, so putting their money where their mouth was, we got a totally different picture. And two things I want to point out to you, and one is that whoa, I guess I'm not going to. This is causing me grief. Food safety, we'd expect that to get about 18% of funding. In fact, it got about 7%, and the same with forage. Everybody said forage was a really big deal, but there wasn't a whole bunch of money going, or not a proportional amount of money going to that. So Now, it's not just, kind of a weird imbalance in where the dollars are going, but actually researchers like Greg, who you're going to hear from, they're impacted very directly too. And one is that research is really, really expensive, and big projects are even more expensive. And to get enough funding to put get these projects underway, researchers have to apply to different funders. And there was one particular project that showed up in there that there were 7 different funders that were involved. And that doesn't mean that project was overfunded. It doesn't mean that researcher was using, was double dipping. What it means is he had an expensive project, needed to get a lot of money to do it. But what that also means is that researcher had to spend a whole bunch of his time doing paperwork, applying for research and getting the contracts underway so that he can accept the money, and administering all the different contracts and grants and all the rest of it that he needed, and then reporting back to all those funders on an annual basis. And so that means he was doing a lot of work shuffling paper rather than stuff like teaching and research and extension that they want to do and that we really need them to do. And so if we can work together and get these funding mechanisms working more efficiently, it benefits us, it benefits the researcher, and then ultimately benefits the industry. So there. Now, the other thing that we did was we, suitably shamed all of the funders, including ourselves, about the consequences of how these bad funding decisions were getting made, and everybody agreed we need to work more closely together. And since you, industry, seem to think you know what you're doing, you can be the ones to coordinate this, so careful what you ask for. And so currently we're working on doing this. So rather than doing this one huge survey every 5 years, we're trying to do it on an ongoing basis. And so we're working with 14 different funders and getting them to tell us every time you're funding new stuff, let me know this information. So they're sending that to us. So far, we're aware of close to 400 projects worth about $87 million that have been funded since our last survey ended. So now what we're doing is we're taking that information, we're lining it up with what we've outlined in the National Beef Research Strategy that all these other funders have bought into as well. And we're comparing where do you say the dollars should go versus where are they really going. So I showed this one to you earlier. This is where the dollars went last time, and this time it's a lot more evenly split. There's still some oddities in there, but it's improving. And something that I'm excited to see is that this first green bar you see here is indicating that most of the funders are putting their dollars towards projects that are really strongly aligned with the National Beef Research Strategy. So that's really good to see. Now, the other thing that I want to point out is that each of our priority areas, like forage and grassland, or food safety, or feed efficiency, or all through the list, we've got that as a priority area, but then we've also got a whole list of specific outcomes that we want to get achieved over the course of the next 5 or 10 years. And here's the point of this whole thing, that if I only knew where the BCRC was putting their funds through the beef cluster, I would see 2 things. And one I would see is that none of these bars go past 7%. So on a national scale, the BCRC is a pretty small funder. We're small potatoes. The other thing that it points out is that there's some of these areas in our research strategy around environmental type research or training and getting new researchers hired that really aren't getting a lot of money through us, through the beef cluster. And so if that's all the funding I knew about, I would think that we need to put way more money into those 2 areas in particular. But I don't just know about that. I know about where everybody else is putting their money too. And so now when I put that into the equation, I can see that, whoa, wait a minute, some of these areas like environment and hiring and training new researchers, they're actually getting a bunch more money than I thought. So what that means is that when we do come across new funding, it needs to go in areas that aren't getting any. So it helps, and this information is being made available to the other funders as well, and so everybody can make more informed decisions about where dollars are most needed. and where areas are getting enough already. So anyway, that's all I've got to say about that, and if you got questions, we can cope with them at the end of this whole session, and I'll throw it back to Tracy now.
Perfect. Thanks very much, Reynold.
Yeah.
Good. So like Reynold mentioned, if you've got any questions for him, just type them into that chat box, and then he'll answer them at the end of the hour. So I now have the pleasure of introducing Dr. Greg Penner. Greg is a professor and researcher at the University of Saskatchewan in the Faculty of Animal Sciences. His research program focuses on developing nutritional strategies to enhance the health and productivity of cattle, not only through basic research, which generally expands our understanding, but also through applied research to figure out how that knowledge can really be utilized to make real-world improvements. So he's an excellent communicator. He's very passionate about doing what it takes to help producers make science-based decisions and modify their practices to improve their productivity and their profitability. And if you've been to the Saskatchewan Beef Industry Conference, which is held every year in January, you'll recognize him. So please welcome Greg.
I think you should be able to see everything now. So first of all, I would like to thank everyone for attending this seminar or webinar, and thanks for the opportunity to present some of the work that we've been conducting over the past little while. One of the things I guess I wanted to do when I was given this topic was to get a better understanding across producers in terms of what rumen health is and the opportunities as well as the challenges associated with actually measuring health impacts. So some of the messages that I hope I can deliver across to you today is firstly, if we're looking to promote rumen health, I think one of the things we need to ensure we're doing is providing those cattle and in the end those microbes a consistent supply of dry matter, abbreviated as DM, as well as adequate nutrients so that they have the tools required for them to do their job. And we'll get into the details of this during this webinar. One of the challenges with this area is that the production responses have not been well characterized. I'll give you direct examples today, but many of the responses have to be extrapolated. Okay? And I think it's reasonable to extrapolate them, but certainly you know, that's an area that we need to really question and investigate further. Finally, one of the things I'm going to try to drive home is that if we're looking for the greatest reward in terms of management strategies, I think it comes back down to basic management and simply minimizing variation for dry matter intake and nutrient intake in your cattle across days. So before we get started, I would like to, I guess, give you a sense of where I see this all fitting in terms of a normal production setting for cattle. So if we start at the top, at least with this flow diagram, there's no way we can talk about rumen health or rumen function without realizing the importance of cattle actually consuming feed. That feed is going to supply all the nutrients that the microbes have access to. So the microbes are completely reliant on those steers, heifers, or cows consuming that feed that you put in front of them. Okay? The good thing that we have in terms of beef cattle production is those microbes are very capable and can quite efficiently digest feed that would otherwise not be useful for cattle. So forages, for example, have complex chemical linkages that mammals like us cannot digest, but because cattle have that rumen before the rest of their digestive tract, the microbes are able to break down that feed and make that forage useful for their own nutrition. Okay? As a result, when those microbes are fermenting that feed, it's giving them energy and it's giving them essential nutrients so that those microbes are able to grow. And as those microbes grow, they're producing byproducts, and we're going to call them short-chain fatty acids or volatile fatty acids, and you'll see them abbreviated as SCFA. And those microbes, as they grow, are producing the most valuable source of protein for cattle. So in reality, what we need to think about is we're not really feeding the cattle, or if we are, we're really feeding the cattle so that the cattle can feed the microbes, and then the microbes can come back and feed the cattle when they pass outside of or out of the rumen. Okay. So to make all of this happen, not only do the cattle have to consume feed, but the cattle have to facilitate that feed consumption as well as other factors to ensure that the rumen environment is suitable for those microbes to digest the feed, suitable for those microbes to grow so that they produce energy and protein and the whole cycle can continue to flow. So it's a really intricate balance where we need to think about not only the cattle that we're feeding, but we also need to think about how the feed we provide to those cattle are going to influence that microbial community within the rumen, how those microbes are going to respond to those nutrients that we provide, and in the end, how they're going to provide nutrients for the cattle in terms of energy and protein, and then how that cow is going to have to respond to that system and those signals to make sure that there are checks and balances in place to keep that rumen in a healthy condition. So really the core of this presentation is trying to drive at what is rumen health. And this is, I think, quite complex and quite open-ended. So depending where you sit on the production sectors, you might think, well, we need to make sure we have good types of microbes. Okay, and from a very simplistic standpoint, that's right. We need to make sure we have the types of microbes inside the rumen for the feed that those cows are trying to digest. Okay, the problem is microbes are not always good microbes, and bad microbes are not always the bad guys. So it's a little more complex than just good or bad types of microbes. If you're in the cow-calf side or on the backgrounding side, adequate rumen capacity will be an issue, especially under Western Canadian conditions or conditions where you're feeding low-quality forage residues or cereal grain residues, and you really need those cattle to consume adequate dry matter so that the microbes can digest what's available and let the rest pass through. And so residence time and passage rates of the digesta within the rumen, as well as the microbes in the rumen, are also important in terms of rumen health. We need to optimize bacterial protein production. As I mentioned in the previous slide, the bacteria are really the major protein source for those cattle. So we need to make sure that that rumen is functioning to optimize that protein production. You might be thinking about the other side. Well, enough about those bacteria in there, they're just doing the work. The cow still has to do a lot of work in terms of trying to absorb the nutrients that the bacteria are producing through fermentation. So maybe we want to maximize surface area or maximize rumen papillae, basically the absorptive structures that stick out within the gut of the digestive tract or within the gut, within the rumen. And with that, you get efficient nutrient absorption. We also might realize that, well, some of those microbes produce products that are not good for the cattle, that they may actually induce an immune response for the cattle. So that tissue shouldn't just be able to absorb those nutrients. It also needs to say which compounds actually pass to avoid those negative compounds from actually crossing into the blood. Again, we want to ensure that we have good fiber digestibility if you're in the cow-calf side or the backgrounding side, and we want to ensure regulated pH. So we have a whole myriad of systems that are coming together, and it's really through the agglomeration of these factors that we actually define rumen health. So with that, I would like to turn the control back over to Tracy for some of the polling questions.
Okay, great. Thanks, Greg. So I'm going to launch a few questions for you guys here one at a time. The first one is, which factor results in greatest risk for compromised rumen health? So you can select whether you think it's high-quality pasture, infrequent forage allocation, newly arrived feedlot calves, feedlot step-up diets, or cattle on full feed. The one with the greatest risk for compromised rumen health? So give you about 10 seconds to submit your answer. And again, this is anonymous, that your responses can't be seen by anybody else on the line. Okay, let's see the results here. Okay, 44% said infrequent forage allocation, 31% said newly arrived feedlot calves, 13% said feedlot step-up diets, 7% high-quality pasture, and 5% cattle on full feed. Okay, our next question asks, what type of operation are you running? So, tell us, are you a seed stock or commercial cow-calf? Are you cow-calf and backgrounding or grassing? Are you focused just on backgrounding, or are you backgrounding and finishing? Give us an idea of what kind of producer you are. Okay, let's see the results. About 40% of you are cow-calf and backgrounding, or seed stock and cow-calf, 40% each. 18% said backgrounding and or finishing. And then our last question for now is, do you monitor and manage cereal grain processing? Give you a couple more seconds to hit your answer there. Okay. That's about an even split. 54% of you do, and 46% don't. So I'll hand it back to Greg. Okay, go ahead, Greg.
Can you see the screen again?
Yep. Just
Perfect.
can't see you.
Okay, so I'm really glad to see your answers. I think we're probably under a similar frame of thought. And what I'm going to, I guess, argue is that regardless of the production system, whether we're dealing with the feedlot side or whether we're dealing with the cow-calf backgrounder side, as many of you are, it's really the challenge that we face is the variation in dry matter intake and nutrient dry matter intake and total nutrient intake. Okay, and the reason for this is that I think when we're dealing with these issues, we're dealing with changes in terms of nutrient supply for the microbes. And so as I mentioned, it might not only be the quantity of starch, but it might be the change in terms of the amount of soluble sugars that could be in forages. And the microbes have to respond to those changes in nutrients that are provided into their rumen and adapt to those responses. Unfortunately, not all of those responses are beneficial. Okay, so certainly if we feed more energy or variable energy, the growth response will differ for those microbes. And at times, if the growth response is not well controlled, there can be harmful products such as antigens that are released. And these antigens, if they cross the rumen barrier, can actually induce an immune response in cattle. In addition to changing the nutrient supply for microbes, we change the nutrients that are actually available for the cattle. Okay? So the microbes will change in association with the type of nutrients provided in the diet. The fermentation profiles will change, and so the cow actually has to also alter how it's using those nutrients in terms of absorption, and then once they use those nutrients after being absorbed. And what I'll also show you today in this seminar is that the function of the rumen, but also function of the whole gut, can be impacted by variation in dry matter intake and nutrient intake. Okay, so sorry, I went backwards. If we think back to what is rumen health, well, I think we need to think about the attributes that go towards providing a healthy rumen. So I thought about this initially trying to look at a forage-based system and a concentrate-based system. And actually, my response to these or to this question was rather surprising to me. So from an attribute perspective, and I hope everyone can agree, or I hope you can agree with these attributes, we want to make sure we have an active microbial population, but we want that microbial population to be regulated. So if we're dealing with forage-based diets, certainly we want that microbial community to be focused on fiber digestion to ensure there's adequate nutrients for the cattle, but also to make sure that they're efficiently digesting those feed components. The cattle then need to be able to utilize the nutrients that are coming from the microbes. So those volatile fatty acids that are released as a byproduct of absorption that serve as the major energy source for cattle. And then again, I mentioned this barrier function property, making sure that not everything the microbes produce, and certainly not pathogenic microbes, should be able to cross that rumen wall and enter the blood. On the concentrate side, surprisingly, the attributes really aren't that different. I think in this case, again, we need an active and regulated microbial community. In this case, probably focusing on starch digestion rather than fiber digestion. We still need to promote nutrient absorption. Maybe it's actually a little more important simply because we have greater production of those volatile fatty acids, and that nutrient absorption helps to regulate that rumen environment maybe to a greater extent on those concentrate-based diets. And then again, we have barrier function. Again, might have a little more higher rating simply because there could be more harmful products produced under this type of fermentation system. So the next question is, well, how can we actually meet or achieve those attributes? And in my opinion, whether it's a forage-based diet or a concentrate-based diet, we need to ensure we have a consistent supply of dry matter and a consistent and adequate supply of nutrients to meet the microbial nutrient demand and to meet the cow nutrient demand. So I thought I'd go through some examples of where we might actually have some of these challenges in conventional production. And I'm going to focus on some extensive feeding systems. So certainly with swath grazing, we know we're trying to reduce costs by providing a system where those cattle can harvest the forage themselves. And if you look at the industry recommendations, we often recommend providing an amount of forage to be suitable for a 3-day allocation. But in reality, many producers are modifying that system and may actually be providing more than 3 days in a given allocation. Well, what's the problem? Well, in collaboration with Dr. Bart Lardner at the Western Beef Development Center and John McKinnon here in the Department of Animal and Poultry Science, we've been able to put some ruminally cannulated cattle out in these extensive winter feeding systems. So these are cattle that basically have a hole in the side so that we can get a first-hand look at what's going on inside the rumen. So in this case, what we did is we had rumen cannulated cattle, and they were on a corn grazing system. We had another group that were on a barley swath grazing system, and then we had another group that were fed, I would say, the more traditional system. In this case, they were fed the same barley as the barley swath animals, but they were fed in a dry lot, and they were fed relatively frequently to minimize variation in feed availability across days. For both the corn grazing and barley swath grazing cattle, we allocated forage into 3-day allotments. So we were able to ensure that there was an adequate forage supply. We provided those cows a new paddock allotment and monitored pH. So I'm showing you duration that the pH was below 5.8, and we use 5.8 as an indication for acidosis. So what you want to look at is basically the bigger the number, the greater the severity of rumen acidosis. So I want to show you a few things with this figure. The first thing is we can see that with corn grazing or swath grazing approaches, we can see huge variation among days within the same groups of animals for how long pH is below that threshold. Okay, what does this tell us? Well, it tells us, one, that either dry matter intake differs across days or nutrient intake differs across days, and perhaps that both dry matter intake and nutrient intake are differing across days. You can see that because of this, the first day that those cattle were in that new paddock, whether it be in a barley swap grazing approach or a corn grazing approach, there was a much greater duration. That pH was below 5.8. It was lower on day 2 and the lowest on day 3. So again, emphasizing that even though we're following industry standard recommendations, we are feeding our cattle in a system that allows for substantial variation in nutrient supply across days. What could be particularly concerning in this case is that in day 1, we might actually be favoring a microbial community that focuses more on starch digestion, then needs to shift for day 2 towards forage digestion or fiber digestion, day 3 probably very strongly toward fiber digestion, and then we go back to day 1 and we're causing fairly large swings in terms of the microbial community structure, probably making it difficult to have a fairly stable environment. Interestingly, when we have a more regular feeding system, and I'm not advocating either system, but when we have a more consistent feeding system, we see much less variation in terms of those rumen fermentation characteristics. So unfortunately, in this case, it's very difficult for us to pick out changes in terms of production, simply because the environment that those cattle are exposed to differs between the extensive grazing system and the dry lot, or the extensive grazing systems and the dry lot. So is it really the change in rumen health, or is it the changes that are occurring within the actual systems that those cattle are housed in? What we do know, however, based on past research, is that when we see pH profiles similar to what we've seen for day 1 and potentially day 2 in the corn grazing and swap grazing calves, is that fiber digestibility is likely compromised. Okay, so if we're thinking about efficient use of nutrients in the feed that we're providing, when we have large swings, and especially swings where pH is dropping quite extensively, we can expect a reduction in feed utilization. Okay. Another example where nutrient intake or perhaps feed intake would be altered could be when exposed to adverse weather. So feedlot operators are quite commonly used to using storm diets to try to manage the variation in starch intake during and after a storm. Something that often isn't thought about is during summer, while those cattle are grazing on pasture, when we have what I would call nice temperatures in terms of a holiday, those cattle are probably experiencing heat stress. Heat stress is a very strong factor that reduces feed intake for cattle. And on the other side, if we have excessively cold conditions, we can also see a reduction in dry matter intake. Beef cows at calving will reduce dry matter intake. Cattle that go through transportation events, newly received feedlot cattle, go through a period of time where they're actually exposed to complete feed deprivation, so no access to feed for a very short period of time, or simply because of the stress associated with that transportation event, have low feed intake for several days, even reports saying it takes about 3 weeks for those cattle to achieve dry matter intakes for what we would expect based on their body weight and requirements. And another example would be disease. So a good example for cattle on pasture for you as a cow-calf operator would be cattle that become lame, whether this be for through foot rot or maybe other infectious disease that limits their mobility or simply reduces their dry matter intake. We've conducted a few studies now to try to evaluate how that variation in feed intake might actually affect rumen health. And so in this study, we're going to call it feed restriction because it's something we're imposing. These are otherwise healthy heifers, Angus heifers, and all we did is measured pH for a period of 5 days, and then we said, well, we want to understand how the severity of that low feed intake actually affects rumen health and animal productivity. Okay? So to do that, we said, okay, we're going to restrict animals to 75% of what they chose to eat, 50% or 25% of what they chose to eat. Okay, so we were artificially imposing a variety of a variety in terms of severity for low feed intake. What we did see is perhaps not that surprising. When we allowed them to eat as much as they want, the microbes responded quite nice, and there was a very adequate supply of nutrients for the cows within the rumen fluid. But when we started imposing that feed restriction, or when those cows would go off feed, as would occur in commercial production, we see that the severity or the amount that they went off feed actually had a direct impact on the amount of nutrients available in the rumen for those cows. So those microbes are responding to that low feed intake, and simply they can't produce as much or the same concentration of nutrients that would have been provided if those cows were able to consume as much as they wanted. We were also measuring rumen pH as an indicator for rumen health. And what we saw, again, followed a same response, where during baseline we saw lower pH, so this was during their voluntary intake period, but I would argue pH was in an adequate range to support optimal microbial fermentation. When we restricted feed, we saw that the amount of feed that was restricted had a direct response to increased pH. Now, I brought this up for a particular reason. We often think of pH from a negative standpoint, where we say, well, low pH is probably going to induce negative effects, but I would argue that we can't simply say low pH is bad and high pH is good. High pH might actually be an indication that animals are not consuming adequate intake. Okay. This is just another way to look at pH, and so this would be the severity of rumen acidosis. So our cattle were only below pH 5.5 for 120 minutes. So clinically, we would argue that's not actually rumen acidosis. And then during the feed restriction, there was little to no risk of low pH. So I mentioned to you in a previous slide that when we reduced nutrient intake by the cow, we reduced the fermentation by the microbes, and so there were less nutrients available as a byproduct of fermentation from the microbes for the cow. Well, we get hit with the double whammy here. What we were able to show, or what we found, was that when cows were going through a feed restriction event, not only were there reduced nutrients available, but those cows had a lower capacity to absorb those nutrients. So again, like I mentioned, a double whammy, and again, it was related to how much those cows went off feed. So the more they go off feed, the less there is available for the microbes, the less the microbes produce for the cattle, and those cattle then also have a lower capacity to absorb the little that is actually there. So not something we want to see in terms of promoting rumen health. On the other side, we were also able to detect that barrier function, so the ability of the gut to prevent non-desirable compounds like antigens from crossing the gut was reduced. But it was only reduced when those animals were on a very severe feed restriction. So for animals that are newly received feedlot cattle or newly received backgrounding cattle that are exposed to a new environment, perhaps multiple stressors like commingling, maybe new disease challenges, and those steers or heifers that really go off feed could be dealing with another challenge that we can't even see from the outside, in that their gut is more permeable and the risk for infection is actually greater. Okay. Sounds like doom and gloom right now, but I'm going to tell you it's not over yet. Okay. We also wanted to know, okay, if there is a problem, is that problem only for one day, or does that problem persist for a longer period of time? So after imposing that feed restriction event, or the period where those cattle only had low feed intake, we offered them the same diet, and we offered the diet so that they would eat as much as they wanted. We wanted to see how fast they would return back to voluntary intake. We did this over 3 periods, so 3 one-week periods. So this is the first 7 days, the second week after feed restriction, and then the 3rd week after feed restriction. And what I want to emphasize is those cows, or those heifers in this case, that were exposed to the greatest severity of feed restriction, so they were only eating about 0.6% of their body weight, not atypical of what happens for newly received calves in a feedlot. It took them almost 3 weeks, okay, at least 2 weeks for them to return to voluntary intake. Okay, and for those calves that were eating already about 2% of body weight, it only took about 1 week for them to return to voluntary intake. So the response in terms of the animal adaptation and the response in terms of the microbial adaptation to promote adequate feed digestion, to promote adequate feed intake, and to ensure there's adequate nutrients available for absorption certainly will impact the response. Again, can we attribute production responses directly to rumen health? Well, yes and maybe no. We imposed very different planes of nutrition in this model. So is the response simply due to changes in rumen health, or is it simply because those cows that we restricted to a greater extent ate less nutrients and so the performance was reduced? Again, something very difficult to tease out under both commercial situations and research situations, but certainly there are impacts that will be felt from a production scenario. The other thing we were able to find out is that when we returned those animals to ad libitum access to feed, remember, all we did is restrict the amount of feed they got. They still received the same diet, and then we gave them ad libitum access. When they got that ad libitum access, they self-induced rumen acidosis. Okay, so you might be thinking, well, Greg, you're probably feeding a pretty fermentable diet to get that response. Well, in reality, we're not. We're feeding a diet that was only about 40% barley grain, and the rest, the 60% remaining in the diet, was forage. Half of that was barley silage, and half of that was a dry grass hay. So not a very hot diet, or not a very fermentable diet that we would think would be high risk for acidosis, but simply changing that rumen nutrient status from very low intake to high intake of nutrients that are reasonably available allowed those microbes to respond in a way that they overproduced, probably overgrew, produced more acid than the cows could deal with, and resulted in further unhappy or unhealthy rumen conditions. We can look at the data really in another way. So this would be looking again at the severity of ruminal acidosis. So during feed restriction, again, no risk. But once we returned those heifers to ad libitum feeding, they spent about 6 hours per day below a threshold that we would think is reasonable to call rumen acidosis. You can see that decreased over time, but certainly we have a period of time where we have a fair amount of variability, and we're imposing variable conditions within the rumen, likely having negative implications on animal health. In terms of nutrient absorption, we can't have positive production responses unless those nutrients are absorbed. And again, we found a very consistent response relative to what we found for dry matter intake, in that those heifers that were restricted to a greater amount, or on your operations, those heifers or steers that go off feed and go off feed to a greater severity take longer to return to normal absorptive function. And it looks like it was taking about, again, 3 weeks for those heifers that were restricted or only eating 50 or 25% of their ad libitum intake. Okay, so the past example I gave was trying to, I guess, use a model that was representative of a number of situations, whether that be beef cattle around calving, or beef cattle exposed to heat stress, or backgrounding cattle in response to a transportation event, or newly received feedlot cattle upon arrival and the challenges they face. One of the other areas where we've been able to look at is actually ruminal acidosis, and thankfully the Beef Cattle Research Council funded a project, or co-funded a project with NSERC, where we were trying to characterize the prevalence of rumen acidosis in feedlot cattle. We would expect that we would have high prevalence rates of acidosis during this diet step-up period, where we actually changed them from a backgrounding diet, as you see in yellow, to a finishing diet, as you see in green. But unfortunately, or fortunately for industry, that wasn't really the period where we found to be the highest risk, probably because during this time, dry matter intake was relatively consistent. What we did see, though, is that midway through or towards the latter parts of the finishing phase, we had a greater risk for ruminal acidosis. Again, this comes at a time where we had environmental challenges, so we had spring thaw coming, and perhaps the changes in pen conditions led to behavioral changes for the cow, where they altered feed intake patterns. That changes how the microbes need to respond, and then the microbes respond according to how the cows are consuming feed, and it becomes a vicious cycle. Okay? Well, or I guess the question becomes, does rumen acidosis actually impact productive responses? And there's been a lot of papers and a lot of extension communication or extension reports that have suggested there's a negative relationship. However, if you look at the data, the results are really mixed. Okay, in some cases, lower pH actually results in greater performance, and in other cases, low pH actually shows maybe a detrimental effect. We took all the data in this study from these finishing animals, and we were able to show that there was a positive relationship, albeit quite weak. It only accounted for about 20% of the variation, but in general, those steers that had higher pH during finishing also had higher rates of average daily gain. And if you're not that worried about average daily gain, perhaps you're more worried about feed conversion, and we were able to detect a negative relationship between feed conversion and rumen pH, where the amount of feed, okay, per unit of gain decreased, or feed efficiency improved for those cattle that had higher rumen pH. So I think this is probably the best example of how we can show that rumen health actually can impact productivity and potentially have an economic impact on your operation. So you still might be sitting back, and based on your survey responses, there was a very large proportion of you that said, well, I'm in the cow-calf production sector, so perhaps that feedlot side isn't really that relevant to your farm. Well, one of the things I want to emphasize is that cows on pasture are not immune to rumen acidosis. So there's very little work looking at actually rumen pH or fermentation profiles for cattle on pasture. Hopefully we'll be able to do some of that work in the near future. But I was able to pull up some work out of Ireland, where they looked at 144 cows spread across 12 farms, fed and managed on pasture. This is a dairy system, so they were also fed less than 2 kilograms a day of supplementary feed at each milking, so about 4 kilos of feed per day. And they used rumenocentesis, which is basically a big needle that they push through the ribs of the cows into the rumen. They take a sample, and then they measure the pH on that sample. And they were able to show that 11% of them had quite severe rumen acidosis, so pH below 5.5, and over 40% of them had pH below 5.8, which for cattle on a high forage diet we would think would be a suitable threshold for rumen acidosis, because below 5.8 we start seeing negative impacts on fiber digestibility. So I think this data highlights that, yeah, rumen acidosis is often focused on from a feedlot perspective, but we shouldn't ignore the cow-calf side or the stocker side, because under high-quality forage situations during summer, we have high nutrient availability, and the microbes may be able to respond more rapidly than the cattle can respond. And perhaps, as I mentioned, in winter, under extensive feeding systems where we have infrequent forage allocation, we might be exposing those cattle to some risk that may or may not be considered in our management decisions. So what are we going to do to ensure that we are providing an environment for our cattle so that they have a healthy rumen environment? Okay, I think I've argued that consistent feed supply is one of those requirements, and when we have situations where we don't provide consistent feed supply or don't provide adequate nutrient and consistent nutrient supply, we have the risk for disrupting that stable fermentation process. Unfortunately, or fortunately, depending how you want to do it, I don't have real good examples in terms of how you can do it outside of the things that you're probably already doing on your farm. Okay, so good husbandry practices, making sure you have adequate feed available on the cow-calf side, ensuring that you are restricting access to extensive feeding systems to ensure that they don't simply go overindulge on those tasty corn cobs or tasty barley cereal grains and leave the fiber for later. If you are using extensive feeding systems, I know of producers that have modified the recommendations and are providing additional forage to ensure that dry matter intake, even though nutrient intake might differ across days, they're ensuring that those cows have adequate dry matter intake across days. So I think looking at general industry practices and following practices of good husbandry is the first point to follow. For those of you on the feedlot side or the backgrounder side, bunk management plays an incredibly important role. Reading those bunks and calling feed based on the behavior of those cattle, based on the amount of feed available in the bunk. And ensuring that when you are feeding grain, and 50% or roughly 50% of you indicated that you are monitoring the extent of grain processing, and that's great. It's something that can be done fairly easily, something that can be done by visual inspection. Not only prevents overconsumption or over-fermentation, but also ensures that you have adequate fermentation of that potentially expensive cereal grain source. There's other products that you can use to help stabilize rumen fermentation, and so ionophores have received a lot of attention in research, and there's an extensive use of ionophores in the beef industry, and they're very effective tools to stabilize dry matter intake by the cow or cattle or steers. They help to manipulate rumen fermentation to make that fermentation process more efficient, reducing methane, improving propionate production, and certainly resulting in greater efficiency of feed utilization. So again, one easily adoptable feeding strategy. Looking forward in terms of the research that I think will be coming out on the beef side, looking at yeast products. So fermentation products, whether this be a live yeast or a killed yeast, these yeast products might provide essential nutrients for the microbes within the rumen. Yeast supplementation, at least on the dairy side, has also been shown to stabilize rumen fermentation. And I would expect that in a cow-calf situation where we're feeding a high forage diet, if we have a requirement to supplement those cows and we're supplementing on a daily basis, there may be an added benefit to putting yeast or yeast-type products in the feed for those cattle. Probiotics is another area that's receiving a lot of attention in terms of trying to stabilize that microbial community structure. There's been some really fantastic work done on the feedlot side where they're looking at specific strains of microbes. So one of them would be Megasphaera elsdenii, which is a lactate utilizer, and dosing that product to try to stabilize and be able to accelerate that step-up period. Some very promising work, some mixed results, but certainly something to watch out for in the near future, and hopefully this becomes one opportunity where research can actually help benefit some of the production practices in your operation. Recovery diets is another issue. I talked already or briefly mentioned how storm diets might be used in the feedlot side. Well, I think this is an area that maybe could see a bit more attention, and we've tried to do this a little bit to try to address some of the issues associated with that low feed intake. So following the same model that we showed or that I discussed previously where we exposed cattle to low feed intake, we wanted to understand, well, can we use simple dietary strategies to actually help those cows or those heifers recover from that low feed intake? So what we did is actually said, well, we're going to feed them a high forage diet because a high forage diet will create rumen fill, it should stimulate rumen contractions, it should stimulate passage rate, and maybe feeding that high forage diet will pose less risk for rumen acidosis as those heifers are resuming feed intake. So we compared that high forage diet, which was essentially 92% forage, to that moderate forage diet, which was about a 40% grain diet. And lo and behold, we found very positive results where those cattle that were fed a high forage diet after a period of feed restriction resumed dry matter intake much faster than those heifers that were fed that moderate forage diet. So I think what we need to think about is maybe ensuring that if we have a situation where we know those cattle were not housed under ideal situations, or it was real hot out during that summer and those cattle were in the feed yard, we might need to think about how to transition those cows to get them back on feed as fast as we can so that we can maintain rumen health and ensure adequate productivity. Not surprisingly, when we fed that high forage diet, we also stabilized rumen pH. So less fermentable substrates going in, even though intake was higher, the cows were able to cope and the microbes were able to cope with that dietary change and the intake change to a greater extent than those cows that were fed, or those heifers that were fed the moderate forage diet. So it looks that from a very applied or a very practical standpoint, if you know those cattle went through a period of feed restriction, and this is already done on the receiving side, we often feed them a high forage diet, and what we're able to show now is that actually stabilizes intake at a greater rate and actually stabilizes the rumen environment to a better value, or to a better point than even a moderate forage diet. So I'd like to bring you back to the take-home messages. I think first and foremost, if we're going to promote rumen health, we need to manage our cattle in a way that allows them to consume a consistent supply of dry matter and an adequate and consistent supply of nutrients. I've taken you through some of the examples, but I'm still going to argue the production responses have not been well characterized, partly because it's difficult to say, is it rumen health or is it the production environment that those cattle are housed in? Okay? Regardless of that, I think we can attribute some of the reduction in performance to rumen health, but we're really doing this by extrapolating the data. Okay? And then in terms of preventing this or trying to remedy this, if you can identify a potential problem, is focusing on management strategies that minimize variation in intake, I think will achieve the greatest rewards for your operation. With that, I would like to again thank the Beef Cattle Research Council for the opportunity to present at this webinar. I would also like to thank them for funding some of the research presented in the webinar, as well as Alberta Livestock and Meat Agency and Natural Sciences and Engineering Research Council, or NSERC, for supporting our research as well. With that, I hope you enjoyed the webinar, and I would be happy to entertain any questions you may have. I assume I will turn the controls back over to you, Tracy.
Yep, thanks very much for that presentation, Greg. Before we give them a chance to ask you questions, we've got one last question for them, which is, same question again, which factor results in greatest risk for compromised rumen health? And you can select all that apply. High quality pasture, infrequent forage allocation, newly arrived feedlot calves, feedlot step-up diets, or cattle on full feed. I'm curious to see if the answers are any different at the end of the presentation as opposed to the start of it. So I'll give you about 5 more seconds to click on your answers. Okay, it looks like most of you have voted, so let's see the results. Yeah, and the results do look quite a bit different this time. So first time around, you had said 7% high quality pasture, this time 19%. First time we had 44% for infrequent forage allocation. It's now 85%. For newly arrived feedlot calves, at the beginning of the webinar we had 31%, now it's 37%. Feedlot step-up diets, at the beginning was 13, now we're at 22%. And then finally, cattle on full feed, at the beginning 5% of you had answered that as the greatest risk, and now 14%. Okay. So So we will now open it up to questions for you, to all of you at home. So again, type your question into the question box in the control panel. If your control panel has closed, you should see an orange arrow near the top. So you can click on that arrow and it'll expand again, and then you'll see that box where you can type your question into. And your questions here are anonymous as well. I'll read them out and then we'll hear from Reynold or Greg. So we had 4 questions submitted already. So one of them for you, Greg, was how long were the heifers in the research on feed restriction before the 3-week recovery?
That's a very good question, and I didn't mention that in the presentation, but we only imposed that feed restriction event for 5 days. So we were trying to, I guess, have a model that would be representative of what we would see in industry, and so we picked 5 days because in newly received feedlot cattle, if you look at least the old reports, they suggest that within the first week they're consuming about 0.5 to 1% of body weight. Within the second week they're consuming about 1 to 2% of body weight. In the third week they're consuming 2.5 up to 2.8% of body weight. So we were trying to pick thresholds that mimicked what we see in industry, and because those thresholds changed essentially by week, we thought it would be appropriate to hold them for approximately a 5-day period. We also thought 5 days would be, I guess, the ideal period, because if we get a heat stress event, it's often not a month of heat, at least in Western Canada, and from my experience also in Eastern Canada, we might see 5 to 10 days of prolonged heat stress. And so we were hoping that this model would be at least a reasonable example of what you might face on your own operation.
Okay, next question for you, Greg. Is giving probiotics beneficial after transportation to a new environment to feed the microbes?
That's a very good question. There was a recent paper published in the Journal of Animal Science where researchers from the University of Kentucky asked that very question. And what they found was that depending on dietary protein, there could be a beneficial response or no response. And so I'm going to give you the typical answer that an academic would give you is, it depends. So there has been some studies showing a positive response. There are also other studies showing no response, and so you really have to look deep into the product that you're using. Some of those probiotics contain live microorganisms, some of them are killed microorganisms, some of them are enriched with other essential nutrients or cofactors, others are not in terms of the carrier, and so there's a wide variety in terms of products available.
Okay, next question. Does protein supplementation for cattle positively affect rumen health, or has that been researched? So
protein supplementation, that's a very good question, and again, I'm going to give you a conditional answer. Protein supplementation improves rumen health if overall dietary protein was limiting. So if you are in a situation such as dormant winter range, where dietary protein might be limiting, feeding additional protein will provide required nutrients for those microbes, and the research is very clear. When you correct for that protein deficiency, it improves fiber digestion, it improves organic matter digestion in the rumen. Cattle often increase dry matter intake, and so you could argue there is an improvement in terms of rumen health. On the other side, when the diet is already adequate in protein, providing additional protein will not result in an improvement. You're already meeting minimum requirements, and in fact you can actually induce some inefficiencies in terms of nitrogen utilization, probably not necessarily affecting rumen health, but affecting the efficiency of nutrient utilization and potentially nutrient excretion for sure.
Okay, a follow-up question is, what about fat supplementation?
Fat supplementation has got a lot of interest, I would say, from industry, and we've conducted a number of projects recently looking at the use of high-fat byproduct pellets. From a rumen fermentation perspective on the feedlot side, if you're replacing starch with that fat, there's no doubt you're going to see an improvement in terms of rumen pH. So we looked at graded levels or different levels of fat supplementation using that byproduct pellet to replace barley grain. And not surprisingly, when we replaced starch in the diet with byproduct pellets, so fiber and fat, we saw pH was improved and the severity of acidosis was reduced. On the cow-calf side or the backgrounding side, one of the major concerns with fat supplementation is that it might actually decrease the ability of those microbes to digest that fiber. So again, we need to think about the production system we're in. I think there might be additional benefits for fat. So one of the things we're looking for now, we actually have a new project starting, is does the type of fat matter? So there's a lot of buzz on the human medicine side and in monogastric research saying that conjugated linoleic acid or CLA could be beneficial from a health standpoint. Well, there's work in animal models to say that that fat might actually decrease the immune or the inflammatory responses, but there's very little done in the cattle side. So we're actually just initiating a study to try to address the question that you just asked. Hopefully in a year to 2 years we'll have a better understanding of whether we can strategically use fat to improve rumen health.
Okay, next question. Will mineral feeding every second day have the same effect as feed restriction every second day?
So the question is whether we need to provide minerals on a daily basis or an infrequent basis. And in all cases, I would argue the only case where this might not be true is with protein or nitrogen, but daily supplementation is clearly advantageous to infrequent or alternate day supplementation when we're dealing with forage, concentrate, or minerals. There needs to be a consistent supply. Realize that the rumen contents don't just sit there. They are diluted over time if new nutrients aren't added, and so the overall supply of minerals will be affected by alternate day supplementation.
Okay, question for you, Reynold. What are some of the current research projects that BCRC is currently funding?
We've got quite a number of them, and I guess to try to keep it focused a little bit on what the topic at hand is, we've got 3 projects going on right now with Greg, actually. One of them looking at acidosis, risk factors and whatnot in different types of cattle. One of them looking at the ability of the gut to absorb the nutrients it needs to absorb while at the same time blocking the pathogens and bad stuff that it doesn't want to get into the bloodstream. And then the third one is with Greg is looking at how or why feed efficiency changes over the course of the feedlot finishing period. There were some questions around pre and probiotics. So we've got there's actually been a fair bit of news in the ag press recently with a guy named Wade Abbott, who works with Agriculture Canada in Lethbridge, and that press is largely around a project that we're funding with him, and looking at pre and prebiotics, which are feeds, like nutrients, specific nutrients that'll help the beneficial bugs in the rumen grow, as well as probiotics, which is really about adding more good bugs to the rumen. And then something called symbiotics, which is when you're doing this, both of them at the same time. And the reason they're doing this is largely because a lot of the research, as Greg indicated, a lot of the research that's out there is sort of, yeah, sometimes it works, sometimes it doesn't. And so these guys are going right back to the start and trying to figure out, okay, what is it about these bugs that make some of them better than others, and try to identify the optimal combination so that hopefully they can come up with a pre or pro or symbiotic combination that works a little bit more predictably than some of the things that are currently out there. I could likely go on, but I'll wait for follow-up questions if there are any.
Okay. Next question for you, Greg. How will the progeny of a highly efficient ruminant cow perform in a feedlot finishing situation?
So that's a very difficult one to answer. One of the I guess challenges is identifying whether that efficient animal on an RFI perspective or a feed conversion perspective in the forage side will translate to an efficient animal in the feedlot side. There's been a fair bit of work done at the University of Alberta trying to evaluate that, and I think they have some good news and some news that says, well, we probably need more information, or we need to evaluate this a little deeper, where in some cases those highly efficient animals on the forage side also can be identified as highly efficient animals on the feedlot side. Unfortunately, and the problem I have in terms of understanding really what's happening is sometimes, even when there is no diet change, some of those highly efficient forage animals become low or lower efficient forage animals even when they're fed the same diet, just going through 2 measurement periods. So I think we might need to really sit back and think, what are the best measures that we can use to identify feed efficiency, and does that definition apply equally across all production sectors? I'm not sure what I want in a forage converter is the same thing in what I want in a feedlot animal, although the requirements in the rumen, I think, are the same. We want an active and controlled microbial community, we want efficient nutrient absorption, and we want to prevent those harmful molecules from entering the blood. So I think it's a very good question. It's a very tough question to answer, and I'm sure there will be work coming out of Lacombe and the U of A in the very near future to address that question further.
Okay, so looking at the time, we're 20 after already. So Greg, I'm going to ask you 2 more questions and then we'll move on. When feedlot cattle are taken off feed for 3 to 4 hours for processing events, is there a need for concern once cattle are returned to the pen?
That's a very good question. We have this is going to be a little bit of a roundabout answer to get at that, but in one of the slides I showed you, we had this very strange spike in terms of prevalence for acidosis in the feedlot period right near the end of our finishing phase. And as a university facility, we're governed by the Canadian Council of Animal Care, and so we want to make sure that we do a very good job presenting to them pen conditions and situations that our cattle are housed. So one of the things we needed to do is actually clean the pads in front of the feed bunks, and so we moved the cattle out of our pens and remixed them within the same treatment group, so it was the same cohort, but one pen was split into 2 pens, and corresponding to those days we saw a huge spike in terms of prevalence for rumen acidosis. So what that made me think about is, okay, is this real or is this just an aberration of our data? And what I'm, I guess, suggesting, and I can't prove it, but I think any remixing event, so terminal sorts or rehandling events, are all factors that cause additional stress. They'll change the feeding behavior of the cattle. They might eat larger meals, or they might eat fewer meals, or go off feed for a greater amount of time than normal. And so all of that combined, I think, will increase the risk for an acidosis event.
Okay, our last question for tonight. What is the link between acidosis and liver abscesses?
So the original work that was done, and this was done in the late 80s, the way they made the link is actually by using some microbial culturing techniques. And so they actually took a sample of the microbes off the inside of a rumen where there was a lesion. They grew those bacteria and identified them, and they actually took a sample of the liver abscess and looked at the microbes within that liver abscess, and they were able to say these microbes are very similar in terms of what they are. So they were basically the same species. So from that, that kind of proved the link, and so the general understanding is that when you have acidosis and it gets to a point where you actually have damage to the rumen wall, the microbes, and in particular we're focusing on Fusobacterium necrophorum, is that bacteria is able to cross that rumen wall, enter the bloodstream, and it's able to colonize in the liver and create that liver abscess. So a lot of the research efforts that we have and a lot of the management strategies that we have focus or aim to try to stabilize rumen fermentation, limit damage to the rumen wall to try to prevent the passage of that pathogen from leaving the rumen and entering the liver. That said, rumen acidosis is not the only cause for liver abscesses. Any systemic infection, so there is an association between respiratory disease and liver abscesses, and there was a very good paper published showing the relationship between a number of infectious diseases, respiratory diseases, and rumen scores, and how they're associated with liver abscesses. So just to summarize all those words that I said, rumen acidosis certainly can be linked to liver abscesses, and that linkage has been proven, but just because you have liver abscesses does not necessarily indicate that you have rumen acidosis.
Okay, great. So for those of you who have submitted questions and we didn't have a chance to get to them tonight, I apologize. If you've got burning questions, feel free to email those to me and we'll try to get an answer to you. Or, of course, you can talk to your veterinarian or your regional extension specialist who you'd likely find through your provincial Ministry of Agriculture to ask them some questions as you keep thinking about rumen health. So there are a couple more important things I wanted to let you know about before we go. One is how to get more information and science-based production advice through the BCRC. So go to our website, beefresearch.ca. That's where you'll also find an overview of all of the different research projects that we're funding right now and all the projects that we funded in the past in short summaries in fact sheets. And be sure to click on that subscribe button to sign up to our free email list. If you've got a Twitter, Facebook, or YouTube account, you can connect with us there too. And I also encourage you to visit the Canadian Cattlemen's Association website at cattle.ca, and where you can sign up to their free newsletter called Action News. I also wanted to briefly mention the National Beef Strategy, which you may have heard was recently released, and so this is pretty exciting. It promotes a united approach to position the Canadian beef industry for greater profitability, growth, and continued production of a high-quality beef product that people have as their top choice around the world. So essentially it's a solid business plan that sets our industry up for success. It's a collaborative effort between the national and the provincial organizations, and it's set measurable goals that the industry wants to achieve by 2020 related to connectivity, productivity, competitiveness, and beef demand. So you'll want to check out beefstrategy.com to see what I'm talking about here, and when you get to that website, the first thing you're going to want to do is take a look at these short videos. So part 1 is only 4 minutes long, part 2 is 3 minutes long, and they're definitely worth watching. And so on the website you'll not only find the full strategy document, but there's shorter versions as well. There's a 2-page summary and a 6-page overview that are quicker, easy ways to find out what the strategy is all about and kind of give you a sense of how it'll guide the organizations in working towards big benefits, not only for the industry as a whole, but for you and your farm's profitability. So check out beefstrategy.com. Our next webinar is 1 week from tonight on how to produce and use forages with a higher sugar content, which has been shown to improve feed intake, milk yield, and nitrogen use efficiency in cattle. This webinar on sweet forages, we're partnering with the Dairy Farmers of Canada and Agriculture and Agri-Food Canada. So I'll be hosting on the evening of the 4th in English, and the Dairy Farmers of Canada are going to host it again on a later date en français, which is French for French. So very shortly, as soon as this webinar ends, you'll be asked to complete a short survey that asks about tonight's session and what you're most interested in for future webinar topics. And we do need your feedback in order to do the best job that we can to deliver information that's useful and meaningful to you, so please do fill out that short survey. And don't hesitate to contact me with questions or comments or suggestions at any time. We're always really appreciative of those and happy to hear from you. So you'll receive that email from me in a couple of days with a link to watch the recording, as well as some links to some additional information on managing rumen health. So that's it. So thanks to all of you at home for joining us tonight, And on behalf of everyone, thank you, Dr. Bergen and Dr. Penner, for volunteering your time and expertise.
Well, thank you.
Good night.
Good night.